So let's review just a little bit. Scientific notation. So if we review it a little bit, if we talk about what we already know, what does scientific notation look like? If you were going to describe scientific notation, what does it look like? Like, what are the characteristics of it, Morgan?
A decimal with only one number in front of it to the left of the decimal.
Okay, so it's a decimal. What else? We'll describe the decimal in a minute. Give me more.
Times 10 to the power.
It's always times 10, right? And then that 10 has an exponent number, correct? All right. So it's a decimal. It's always times 10. And then there's some form of exponent. All right, so who can tell me characteristics of the decimal? The decimal has to be a very specific type, or has to be written a very specific way. Come on, guys. You can do it. Morgan already said it. What? Tell me about the decimal. Turn back a few pages. Read about it. Tell me about the decimal. Julia. So the decimal, right, must have one non-zero digit to the left of the decimal. Right? The decimal must be a one non-zero digit to the left. So like 8.4. Does that work? 0.3. Does that work? No, because it's a non-zero digit, right? Can't be 0 point. It has to be a non-zero digit. What about 10.3? Is 10.3, why not, Kevin? Well, 10 is a how many digit? It's a 2-digit number. What about 13? It's a 2-digit number, right? The only numbers that work are 1, 2, 3, 4, 5, 6, 7, 8, 9. Or -1, -2, right? Negatives are okay. Okay, what can you tell me about this exponent? What do you know about the values? What does the exponent tell you? What does the exponent in scientific notation mean, Zoe? There are two types of exponents, right? What and what? Scientific notation either has this type of exponent or this type of exponent. Page, help her out. Positive or negative? If it's a positive exponent, what does that tell us? Goes to the left. Give me more. Generalities. I know goes to the left, but what kind of answer is it if it's positive? If it's a positive exponent, the answer is a big number, right? If it's a negative exponent, what's the answer? A small number. Meaning it's a 0 point something, right? It's less than 1. Now again, negatives kind of, like negative decimals kind of screw us up with this whole big and small. Okay, so today we're going to add and subtract scientific notation, and I'm going to tell you this. If you do not remember or understand or get home and forget or all those things, right? If you don't remember or understand these rules, when in doubt, write it out. That's going to work. Now, what did we learn about this rule of when in doubt, write it out? What do you know? Is this a shortcut? Is when in doubt, write it out a shortcut? No, it's way more work, right? But it's still going to get you the right answer. Here we go. If I give you the number 4.3 times 10 to the 5th, is that scientific notation? 4.3 times 10 to the 5th, is that scientific notation? Yeah. It's inside parentheses mainly to show you that it belongs together. The parentheses don't have anything mathematical to do. They're just grouping them, showing you that they belong together. And I'm adding 4.3 times 10 to the 5th to 1.2 times 10 to the 5th. Now here's my dilemma. I don't know what to do. We haven't had any rules yet. We've just got this problem. So let's pretend we don't know what's going on. When in doubt, write it out. So 4.3 and 10 to the 5th, so that means I move it 1, 2, 3, 4, 5, correct? And fill in with zeros. Plus 1.2 times 10 to the 5th, so 1, 2, 3, 4, 5. Oh wait, I know how to do this, don't you? I mean, this is just adding, right? Grab a calculator. What is 430000 plus 120000? Zoe, what'd you get? I agree. Now here's the bummer. If the problem's written in scientific notation, guess what your answer should be written in? Scientific notation. So I'm going to have to take this and change it. Here's my decimal. 1, 2, 3, 4, 5. So my scientific notation answer is 5.5 times 10 to the 5th. And that's it. I did it. When in doubt, write it out. Did it work? Yeah. Anybody see a shortcut? Kevin. Say again. I think you're right. So the decimals. But what else do you notice about these two problems? So Kevin's saying add the decimals. What else do you notice? Or Aaron? Do you add the exponents? Five plus 5? No. So what do you do to the exponents? The exponents are the same, correct? And in the answer, is the exponent the same? Paige.
So the exponents are the same.
So here's the rule. Here's the trick. If the exponents are the same. If the exponents are the same, add or subtract, right? What if it's a subtraction problem? The decimals. If the exponents are the same, exponent of 5, exponent of 5. Yep, they're the same. I can add the decimals. 4 plus 3 plus, or 4.3 plus 1.2. What's 4.3 plus 1.2?
5.5.
5.5. And then my exponent stays the same, times 10 to the 5th. Easy, right? I mean, doesn't that... right? Am I crazy?
No.
Okay, let's try it. Ready? Let's do... this one. Oh, I want to change that, sorry. We'll do that one later, so you can just skip down here. Uh, 10 to the negative 4th. But I'm going to skip that. We'll do that one in a minute. We'll come back to that. Let's do this one. 3.1 times 10 to the 4th plus 2.5 times 10 to the 5th. (3.1) times 10 to the 4th plus 2.5 times 10 to the 5th. Can I use my rule? I heard no's.
No,
Why?
the exponents are different.
The exponents are different. But wait a second. If the exponents are different, make the smaller exponent match the bigger exponent. If the exponents are different, I can just change it. I'm going to change it. I'm going to make the smaller of the two exponents, because I have an exponent of 4 and an exponent of 5. I'm I'm going to make the smaller exponent, the exponent of 4, I'm going to make it become a 5. You ready to see how? If my decimal's right here, and I'm going to move my decimal, I want my decimal to move so this 4 becomes a 5. How many times do I have to move this decimal? If I want my exponent to go from a 4 to a 5, how many times do I have to move it? Once. Ready? Right there. Bam. One time. I moved it one time. So what does my first scientific notation look like now? It's not 3.1 anymore. What is it? 0.31, right? Times 10 to the 5th plus 2.5 times 10 to the 5th. Do they match? Yeah, they match. So, if the exponents are the same, add or subtract the decimals. What's 0.31 plus 2.5? What? 2.81 times 10 to the 5th. And we're done. If this doesn't make sense, what can you do every single time? When in doubt, write it out. All right, let's try this one. 1.8 times 10 to the negative 7th minus 3.4 times 10 to the negative 4th. Do the exponents match? No. If the exponents are different, make the smaller exponent match the bigger exponent. Which one's smaller? Negative 7 is smaller. Remember, negatives switch it around on us, so don't get confuddled. All right, to make negative 7 become negative 4, what do I have to add to it? 3, so I have to move it 3 times. Are you ready? 1, 2, 3. So what's my answer? Or what's my new problem? .0018 times 10 to the negative 4th minus 3.4 times 10 to the negative 4th. Now, do my exponents match? Yes. Subtract the decimals. 0.0018 minus 3.4. I use a calculator. .0018 minus 3.4. Pre-made, you get it? Negative 3 what? 398. 2. Is that correct? Times 10 to the negative 4th, right?
So you would be able to like round it up. You have to put all the numbers.
All right, here's some practice. I'm going to give you 4 problems. Try them at your table. To make 5 become an 8, you move 3 times. 1, 2, 3. So 0.0048 times 10 to the 8th plus 4.2 times 10 to the 8th. The solution is 4.2048 times 10 to the 8th. Second problem. To make 6 become 7, what do? Move it once. So 9.8 times 10 to the 7th minus 0.59 times 10 to the 7th. 9.8 minus 0.59 is 9.21 times 10 to the 7th. Okay, -4 and -5, which one's smaller? -5 is smaller, meaning I move it once. So 7.4 times 10 to the -4th plus 0.98 times 10 to the -4th. The negative exponents screw us up every time because you forget -5 is smaller than -4. Making an answer of 8.38 times 10 to the -4th. Okay, 7.9 times 10 to the 5th and 9.9 times 10 to the 6th. 5 is smaller, right? So move it one time, making it 0.79 times 10 to the 6th plus 9.9 times 10 to the 6th. 0.79 times 9.9 is 10.69 times 10 to the 6th. And if you put that down on your paper, I'd mark it wrong.
Yeah. The decimals in the wrong place.
What kind of number is this? It's a 2-digit number, right?
Oh, yeah.
So we have to move it one time. So the answer is 1.069 times 10 to the 7th. Ladies and gentlemen, if you did all these practice problems and you just thought to yourself, what in the world?